Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Uh, I have how many things I have? I have three things, but I will say first one. First one, I have posted a group assignment in the OL, right? And go back and read the question first. All the questions. Okay. And like after you read the question, each question, you highlight or anything you wanna ask, you can ask me tomorrow. Okay, so just go back and read anything you want, like, oh, what does it mean here, sir? What does it mean? Okay, ask questions tomorrow, then I will explain. Okay, because your group assignment is 20%. If you see, like, the total mark for group assignment is 140 marks, which is a lot, and you have like 3 weeks to complete. Okay, and the weightage is 20%. Like that is like 1/5 of your final grades. So I hope you can score as maximum as possible. You can get 140 obviously, because this one is maths. Okay. And for the members, I think last time I said 5 members, but my friends, like when I read the assignments, like it says 3 or 4 members. Okay. The bad thing is you cannot choose your member. If you see, like I posted a name list there. Let me see here. Oh, I can show from here. Yeah, I shared this one in the OL too. You can see like we have like blue and yellow highlighter. Alright, and here you see that we have like 1, 2, 3 until 8. So what do you think? Okay, so the first 4 one is like group number 1. The second, like the first yellow there is group number 2, and so on. You cannot take your members. You have to like follow. This is like your allocated members. Okay. I share this one in the OL too. Alright. So if you have like your friends in the same group, then you are lucky. And on the other hand, if your friend is not in your group, then make a new friend. Okay, check this one. I will continue now. Okay. All right. We have covered mean, and we have covered median. Okay. Now next one is mode. Okay. So what is mode? So basically, like the mode of a data set is the value that appear most frequently. So the keyword here is appear most frequently. What does it mean? Like it should have highest frequency. Okay. Alright. And second point here, even though like we cover like the measure of central tendency, but the locations of the mode is not really around the center. Okay. And for instance here, you can see this is the mode. Do you agree this one is the mode? Do you agree this one is the mode?
Yes.
Yes, because like it is the tallest one. Right? Alright. And the third point here, if two or more values are tied for the most frequent, they are all considered to be modes. What does it mean here? If we calculate mean, we should have like one value of mean. If you calculate median, then we have like one value of median. But for the modes, like if you have like, let's say like this one, the rectangle is the same height, then we should have like two or more modes. We can have that because it depends on the frequencies. Okay, so the mode is slightly different compared to mean and median. And last one, if no value appears more than once, we say that the data has no mode. What does it mean? Like if you don't have like the value, like let's say we have like 1, 2, 3, 4, 5. There is no modes there because 1 appear 1, 2 appear 1, and so on. So the mode may exist or may not exist. So if exists, probably like we have one mode or two or more. That is like slightly different mode with the mean and the median. Okay, and based on the graph here, obviously we can say, oh, this is easy to identify the mode. Yes, if you have like a histogram here or rectangles here. Alright, so here it says mode is not unique. What is unique? Yes. And I'm sure you have heard the word unique before. Unique is like one, not one. Okay. So first one, we have like a data set with each value occurring only once. We have like 3, 4, 5, 6, 1, 2, 7, 8. Do you have modes there? No. So the first example, we don't have mode. So basically, the mode does not exist for the first example. Right? Second one, we have like a unimodal, a data set with only one value occurring with the highest frequency. So here like one value occurring highest frequency. So we have like 3, 4, 5, 5, 1, 2, 7, 8. Which one is the highest frequency? 5. So the value is 5 because there are like 2 5s there. Okay. And third one is, this one because of one value. Okay. Next one is we have by models here, a data set with 2 values. So like by 2 values. Okay. Highest frequency. And our example here we have like 3, 3, 5, 5, 3, 2, 5, 8. Right? So which one is the highest frequency? 3 and 5, right? Because like 3 we have 3, 5 we have 3. Okay. So why by model? Because we have 2 values here, 3 and 5. Okay. And next one is multi. What is multi? Banyak. Multitasking. Okay. So more than 2 values. Like probably we have like 3 different values. 3 or more. Okay. With the highest frequency. Question. Alright, now we have to compute the mode. Previously, based on the histogram, we can identify, okay, this is the mode. Easy. Okay, so now we have to compute the mode. And again, we go back to basics. We have ungrouped data. We have group data. Okay, so what do we have here? Okay, for ungrouped data, obviously this one is easy. Like the previous example is ungrouped data. Agree? So all of these are ungrouped data. Do you agree? Yes. Why? Why you said all these data are ungrouped data? Because why? Ani. Why? Why ungroup data? Sebab dia tak susun. Okay, I need to say like sebab dia tak susun. Najma Dayana. Yes, correct. Yeah.
Because there is no class interval.
Yes, because there is no class interval. What is class interval? Huh. Somebody draw something on the air, guys. At least like she knows something. What is class interval? Janatul Adenin. Yes, what is class interval?
6 to 12.
Ah, yes, 6 to 12 and so on. That is class interval. Okay. Alright, so for ungroup data, so obviously you see which one appear the most. Then you can get, okay, this is the mode. Okay, and could be more than one. Just now like we have not unique, unimodal, bimodal, multimodal. Right? And for group data, right? Like previously, when we calculate the median for group data, we have to find the class median, right? So this one we have to find the class mode first. Okay. How to identify the class mode here? Go back to the definitions, like mode should be highest frequency. So class mode, we should have highest frequency too. Okay. And median, we have formula, right, to calculate for group data. And we do have formula for the mode. And the formula is like mode equals to LMO plus the difference between 1 divided by difference 1 plus difference 2 multiplied by I. Okay. So the formula is nice, and obviously mode is modes here. Okay. So MO here refer to mode. Okay. So what is capital L's there? This one it says lower boundary. Okay. Don't confuse it lower limit and boundary. Okay, we have limits, we have boundary. Okay. So LMO is lower boundary of the class mode. So we need to identify which one is the class mode. Okay. And plus, and then we have like difference here. Okay. So it says here difference. What does it mean? Like the difference between the frequency of class mode and the frequency of the class before the class mode. What is difference? How do you get the difference normally? Tolak, right? Okay, so basically here it means like, okay, we need to have something like tolak. Okay, tolak what? Take the class mode, the frequency from the class mode, minus the frequency before the class mode. Okay, right? And this one is the same, like if this one is 5, this one should be 5. Okay, and next one we have like this one. We also have like difference. So obviously we have to tolak again. Okay, tolak what? Class mode. And here it says like after. So what we call this one? Delta. Delta 1 is like we take the mode class minus before. So delta 2 like we take the difference between the model class and the class after. And we will see later what is before and what is after. That's why we need to identify the model class first. Okay, and last one is I. This one is not iPhone, obviously. So what is I then? Class width. And how to find class width? tambah semua. How to find the class base? Tak ingat dah. Because you enjoy your sukan asasi. Different between lower limit consecutively. Yes, different between lower limit consecutively. Okay. Don't worry, you will do calculations later. Okay. Alright, this one. Okay. 10 students were asked how many siblings they had. The result arranged in order were like 0, 1, 1, 1, 1, 2, 2, 3, 3, 6. So find the mode of this data. Answer? 1? Agree? Why 1? Because it has the highest frequency. The keyword is like when somebody asks you why you pick 1, obviously the answer is 1 by looking at the data there. So the reason is like because like 1 has the highest frequency. Okay, that is like the strongest keyword, or you can say like because 1 appear 4 times. As long as we know, because 4 times is the highest frequency. So don't miss the keyword, guys. Because your assignments, you have to interpret something. Don't miss the keyword. If you miss the keyword, then I will miss your 1. Okay, I'll give you 0 then. Okay. And I don't know, the second one is probably examples too. So what is the mode for the second one? No. Why no? Okay. Question. Is it hard? Or like you say, okay, this is easy. Alright, so this one, it says the mode for group data, right? Do you agree this one is group data? Why? Class interval. Which one is the class interval? 0 to 49, 50 to 59, and so on. Okay. I need to check this one, guys, because like my understanding is different. Let me check first. Okay. Okay. So what is the formula here? Like this is like the number of text messages sent, and we have like frequencies there. And this one is group data because of we have like class interval 0, 49, and last one is 250299. Okay. So to find the mode, so we have to find the model class. Okay. So which one is the model? This one is example. Okay. Which one is the model class? Because we have to identify the model class first. Which one is the model class? So out of this interval, which one has highest F? 13 is the highest. Agree? So you agree this one is the highest one. So which one is the mode class? So this is like identify the model class. How to identify? Go back to the frequency, pick the highest one. So this one is the model class. Okay. And the formula here for the mode, so we have like mode. So first one we have L, capital LMO. What is capital LMO, if you remember? Lower boundary. Okay. So this is our model class. What is the lower boundary there? Shazwan? 99.5. Agree? Agree 99.5? Okay. So this one is 99.5. How do we get 99.5?
49 plus 90.
This one plus this one divided by 2. Okay? And then we have 99.5 plus, right? So first one we need to have like delta 1, right? What is delta 1? Delta 1 is different between like class mode and before, right? So which one is, if this one is the class mode, obviously this one is the before one. If this one is the class mode, this one is the after one. Okay? And what is delta 1? It says like the difference between the class mode and the class before. Right? Don't take the class interval. Take the frequency. Okay? So we have to take 13 minus. So 13 minus 5 is 8. So that's why we have 8 there. Because it say they're different. You can put 13 minus 5 there if you can. Okay? So if this one is 8, this one should be 8 too. Right? And plus we have delta 2. What is delta 2? Difference between class mode and after. So which one is after? 11. So what do we have to do? 13 minus 11, which is 2. Okay? And for delta here, you cannot have negative. Because mode is the highest one. Obviously, if you take the highest one minus like not the highest one, obviously you will get positive. So if you have negative there, it means like you pick the wrong model class. Okay? So done this one. And last one we have to multiply by I. What is I?
Class width.
Class width. And what is the value here?
The bottom.
What is the class width here? 50? How do we get 50? Yes, we can take like 250 minus 200, 200 minus 150, 150 minus 100. So answer is 50, right? Okay, so what is the answer? Satu tiga 9.5. Agree? Agree? Okay. So before we proceed, questions. How do we get this number? Because I'm not worried about the formula, because like formula you can Google anywhere. Alright? The problem is like you might know the formula, but you don't know, okay, what does it mean? Each letter there. Question, and make sure you know, okay, how do I get 99.5 and how do I get 8, 2 and 50. Question. Okay. Alright, and for the median last time we did approximate, right? Like after we have ogive there, then we took the middle value and then we read from the graph. That one is approximate. Okay, like if you want to calculate, then calculate. Okay, so like this one, I don't know, this one is okay. This one is the histogram from the previous example. Okay, and this one we want to approximate. Why we want to approximate? Because we don't use formula. So if you use formula, then we have like correct or exact value. Okay. So now we have histogram. Then we want to approximate. Okay. So based on the histogram here, alright, and this one is number of text messages, and this one is frequency. Okay. And we do have values down here like negative 0.5, 49.5, 99.5, and so on. What are these values? Because you will plot your histogram in your assignment, guys. So what are these values? Where do you get it? Because if you compare with the previous slide, we don't have like negative 0.5, we don't have like 49.5. But here, suddenly we have. This one is lower boundaries. Okay, clear? Alright. And so based on the histogram here, can you identify which one is the highest one? Obviously this one. Agree? Why? Tallest one. Okay. Okay, so basically, so when we identify this one is the model class, and you can see here like the values is 99.5 until 149.5. Right? So what does it mean? Our model is like from there. The range is from there. If you have like MCQ questions like A, B, C, and D, so you can ignore, like you can remove outside the range there. Okay? And how to get the histogram? How to get the modes here? Have you done it before? You have to take like a ruler, alright? Then you have to like draw like two straight lines. How to draw this one? Because I don't have ruler, guys. Like draw this one, and like from this corner to this corner, the diagonal one, right? And this one is from here to here, like from the this one, like you have to like don't draw straight line here, diagonal one, like from the highest here to the lowest here, and from the highest this side to the lowest this side. Clear? Now, to approximate the mode. Just now, this one, 99.5 until 149.5, that is the model class. So we know like our answers is like from here on. Okay, so to get the modes here, we have to take like straight lines here, from the highest one to the lowest one here, and highest here, lowest here. Okay, so after you draw these two lines, you can see like there is a cut, or there is like intersections point there, correct? So which one is the intersection? This one, right? Right? So what is the importance of the intersections there? Draw straight lines down, like the vertical one. Okay, so here it means like this, I cannot read the values from there. Okay, but if you use like a graph paper or probably software, then we can get the value from the graph paper. Okay, so this is the mode. Okay, and so why we call this one is approximate. Okay, so if you use graph paper, sometimes like the intersection point happens in the box, in the small box, right? Then you start, okay, probably you will write 139 or 138. So it's okay, because you want to approximate only, not the exact value. Question? Question? So which one is easier, approximate or the formula? Obviously, I would say formula, alright? If you have like the tables then. But if you are given a histogram, then you don't have options. Probably you have. Yes, you can. You can use histogram to calculate the modes using the formula, because we know the frequency. What is the frequency here? 13, right?
Yes.
What is the frequency here? 5. What is the frequency here? 11. So we can use the formula. So it depends on question. Okay. Question. Question. Good. Okay. So we done median, and then we done mode. All right. So now properties of mean, median, and mode. So first point we have here, the mean and the median can only be computed for quantitative data. So what is quantitative data? Number of something, right? Like number of marks, number of siblings, all right? Number of gold medals you got from Sukan Asasi, etc. Okay, that is quantitative data. Okay, number of goals. Okay, so this one's but the mode, on the other hand, can be computed quantitative data and qualitative data. So what does it mean here? So what is qualitative data? Color of hair, blood type, etc. Okay. So we have examples here. Like we have like Honda, Chevrolet, Toyota, Nissan, Dodge, Ford, what else? Okay. So this one is quantitative or qualitative data? Qualitative data. Alright. So when you see this qualitative data, if I ask you to calculate, find the mean. Can we calculate the mean? Cannot. Like, what is Toyota plus Toyota? Toyota Square or 2 Toyota? Cannot. Because it's qualitative data, so we cannot add them. That's why we cannot calculate means here. Can we calculate medians then?
Yeah.
Median? How do you sort? Which one first? Honda first, Ford first, or Nissan first? Can we sort? No, we cannot sort. Because probably you may argue like, oh, how about we sort using alphabets? Like A first, B first, second, and so on. No, we cannot. Because sort, we have to like sort the data either from smallest to largest, or largest to smallest, not alphabetically. Okay, so this one is qualitative data, so we cannot find the mean, we cannot find the median. Okay, can we get the mode? Mode, yes, we can. Because mode, we don't have to add something. We just see which one is like highest, which one has the highest frequency. So here you have to calculate how many Hondas we have, how many Chevrolet, etc. So based on answer here, I believe Toyota appear the most. Alright. So we have the mode, but we don't have like the mean and the median. Okay. So that is the importance of quantitative and qualitative data. Don't get too excited to calculate mean, mode, median. No, mean and median. Okay. So check your types of data: qualitative or quantitative. Clear? Okay. Then next we have the median is resistant, but the mean is not. Okay, we will see here. I think we have examples. Okay. So 5 families, names, etc. Their annual incomes in dollars are 25,000, 31,000, 34,000, 44,000, and 56,000. Okay. So this is the first data. Can you calculate using this, the first data here? Can you calculate the mean? What is the mean now? Can you calculate now, please? What is the mean? 38. 38? 38,000. Okay. Why you afraid, guys? Don't worry. And what is the median? $34. Okay. Agree? Mean is 38,000. Median is 34,000. Alright. Now, the Smith family, whose income is 25,000, wins $1 million. Wow. Okay. If you win $1 million, then you can stop learning. Okay. Go somewhere. So their income increased to like 1,025,000, right? So what does it mean here? Now, after they win the lottery, obviously their income is no longer 25,000. Okay, their income now is like 1,025,000 there. Can you calculate the new mean? How to calculate the new mean? Don't use this value, but use this value now. Get it? Because they win a lottery, so their income now is like no longer 25,000, 1,025,000. So what is the new mean? Two. Correct? Alright. That is the new mean. And what is the new median? Like, what is the median now? $44,000? Okay, correct? 44,000. Agree with the answers? Can you see how do we get these values? Okay. Yes? Alright, now it said the median is resistant, but the mean is not. This is the point, right? So what is resistant here? Alright, like very strong. Okay. So you can check here. We are talking about the median first, right? Even though like we have like very huge values here, but the median is almost the same. Like the difference between like the median before and the median after is not that huge, correct? Like you see that? Like the difference is only like 10,000. Okay. If you see the second point, but the mean is not, which means it's not resistant, like it's not very strong. Why? What is the means before? 38,000. What is the mean after? 238,000, right? Can you see the difference there? Which one is higher? For the mean, right? Mean is higher, right? So like if you can see the difference before and after, so like the smaller one is resistant, the higher one is not resistant. That is resistant. And how to see? Yeah, you have to see the difference between before and after. Okay, clear? That is resistant, guys. Okay, but the question here is, understand the resistance then? Like which one is like does not affect if you have huge value? Median, because the difference is like very small. Don't compare, like you may say, but the value is different. Yes, the value is different. But if you compare these two, which one is like the difference is higher? Mean compared to the median. So if you have the difference is lower, then it is resistance. Okay. So second one, which measure of center is more influenced by the large number? This is the question. Which measure of center is more influenced by the large number? Mean or median? Mean. Why you say mean?
Average.
Because you can, not the average, because you can see the difference is very huge. Okay? Question. Make sure you know what is resistant, what is, at least you know what is resistant. Alright. Question.
Macam mana dapatnya after tu?
This, how to get this 44,000? You substitute the 25,000. Don't use the 25,000. Remove the 25,000 there. Substitute with 1,025,000. Okay. And how do we get 138 there? Take 31,000, 34,000, 44,000, 56,000 plus 1,025,000 divided by 5. Okay. Question? Alright, next one is describing the shape of a data set. Okay. So what is shape here? Not circle, not rectangle, not square. Have you heard the shape like in terms of mathematics? Yes or no? Yes or no? Yes, somebody draw something on the air. Correct. Have you done it before or have you learned it before? Yes. We have covered it. We have covered. So what is the shape here? We are talking about skew to the left, skew to the right, symmetry. That is the shape. Okay. And last time when we identified the shape, we use histogram, right? Like if the rectangles are on the left, then skew to the right. If the highest rectangles are on the right, skew to the left. Okay. That one is based on the histogram. Okay. So now we want to identify the shape, but based on the mean, the median, and the mode. That's why we calculate these three. Okay, because next we want to identify the shape. Okay. And symmetrics. What is symmetric? Sama. What is the shape of symmetric? How? Like this one. This is symmetry, right? So this one is symmetry, correct? Right? So what does it mean here? No. So the point here is, if symmetric, the mean and the median are equal. Okay, so mean, median equal, symmetric. Okay, so next one we have like skew to the right. Skew to the right, what is the shape? How is the shape for skew to the right? This one? Skew to the right, like? You see the tail, like going to the right. So this one is skew to the right. Okay, and it says here like mean is often greater than the median. Okay. What else? Skew to the left. How is the shape? Oh, now you sketch. Okay. Probably this way, guys. Okay. This one is skew to the left. Agree? All right. So this one, the mean is often less than the median. Okay. So question now is, I guess like I don't remember this like mean greater than the median, etc. But I remember the shape here, right? Like this one is symmetric, second one is like skew to the right, and last one is skew to the left. Make sure you know the shape at least. Okay? right? Okay, so this one is skewed to the right. Median greater than, no, mean is greater than median. Okay, let me see this one. It says what? Skew to the right, mean greater. Okay, so this one we have like median is there. Oh no, first one, do you agree like this shape is skewed to the right? Yes. Okay, and this one is normally for x, like your values, and this one is like normally the frequency. Okay, so here if the median is here and the mean is here, can you see like mean is greater than median's then? Okay, so because mean is greater than median, why mean is greater than median? Because when you plot graph, normally this one is 0, 1, 2, 3, 4, 5, 6, right? The numbers is like getting higher, right? So based on this position, we can say, okay, mean is greater than median. Okay, that's why this one is skewed to the right. Okay, this one skewed to the left. Agree, skewed to the left? This one is X, this one is F, frequency. So now which one is higher? Median or mean? Median. Why median higher? Like because of the locations or positions. Okay. So question, sometimes they ask you question like where is the mode? Yes. What is the definition of mode? Highest frequency, right? So if you look at the graph here, which one is the highest one? The tallest one. So this one, right? So mode should be somewhere. You cannot put your modes there. Wrong. Because obviously this one is not the highest one. Okay? Alright. This one is like symmetric one. Okay. Mean equals to median. Right? And what is the mode? The tallest one. Okay. And this one it say approximately the same. So in theory, yes, we can say mean equals to median. But in practical, like it's very hard to get like exactly like 20-20 that. Okay, that's why we say approximately the same. Okay, this one I think like this one is like standard one example. Go back and do yourself. So we see which one is higher, which one is lower. Then decide the shape of the distribution. Okay, that's why we calculate mean, mode, and median. Okay. So what can go wrong here? If your mean is wrong, your median is wrong, then your shape is wrong. Luckily, like probably like if you get wrong, but the position is like still the same, then your shape is correct lah. Okay, that is the importance of mode, mean, and median step. Okay, this one go back yourself. Okay. Alright, so advantages, interpretation when to use. These ones, I don't want to explain this one. Okay. I guess this one, you will ask me this question when you do your assignment. Then I will answer your question. Okay, if I explain now, like, you take it now, then you will leave it somewhere. Then during assignment, you will ask me again. Okay? Okay? Examples 9. Okay, nothing's there. Alright, I think this is the last slide. Critical thinking. Okay. Alright, this one is the last one. What is the time now? Oh, See this one. Questions. This one is X bar, guys. X bar. See this one. Again, like I said before, I'm not worried about the formula. I'm worried about like you see the formula but you don't know what does it mean. Just take a look at the formula and ask me question. Good. One more thing, my advice is like, again, I'm not worried about the formula. Okay. Like make sure you know what does it mean. Like sometimes you know the formula, but okay, you can Google it, you can ask your friends, but you don't know what does it mean. Okay. And YouTube to probably like you will like use YouTube or any other like webs to study. Like if you have like contradicts with what I share here, let me know, because sometimes when I see YouTube, like the videos they cover or the theory they cover, sometimes it's wrong. Okay, so when you have like contradicts explanations, clarify, because I cannot stop you from watching TikTok video, etc. Just clarify. Okay. Question? Good. Then yes, this one, go back and do this one yourself. Then alright, next one is keep or discard. Keep. Alright. Before that, scan your attendance first. I need to take. If you have scanned. Okay. You can have your biscuits now. You can enjoy your biscuits, okay. You look exactly like my ex-students in KMP now. What is his name? I can't remember. Like I teach him like in kuliah, but it's not from my tutorial. So like kuliah we have like 200 students. So I cannot remember the names obviously. What is his name? Later I ask my friend. Oh, Mio. His name is Mio. Mio. Done? Your attendance? Do I have 30 here? Who's not here? Where? So kan Ansasi, kan dia salah balik ikut bas? Alright. Ready? We won't stop at 10:30 guys. Okay, because we have one more class tomorrow. Right, tomorrow. Because like, yeah, okay. Alright. Okay. This one is dispersion measurement or measure of dispersion. Okay. And previously we covered the measure of central tendency. Okay. Previously. So if the question asks you to calculate measure of central tendencies, what you have to calculate? Mean, median, and mode. Okay. Why we call it central tendency? You can see like the locations of the mean, median, and mode slightly around the center. That's why we call central tendency, like going toward the center. Okay. This one is measure of dispersions. Okay. How do I say this one? Measure of dispersion is like when you do normal conversations, sometimes we can say like plus or minus 5 minutes, right? Probably I don't know what conversation, but probably we can say like plus minus 10 ringgit. Okay, but you don't know the exact value, but you know, okay, around there. Probably like when somebody asks you around, like, what is the price of, I don't know, earbud, for instance. Probably you can say like around 1,600, for instance. Okay, around that. Probably like 1,590 or probably 1,610, but you know, around that. Okay. Alright, so this one, so when we are talking about measure of dispersions, we have to calculate this form. Like measure of central tendency just now, we have to calculate 3. Dispersion, we have to calculate 4. Okay, so first one is range. Second one is interquartile range. Third one is variance. And last one is standard deviations. I think most cases, I think you're familiar with the variance. And you're familiar with the standard deviations. Okay. Alright. And we have to calculate for group and ungrouped data. Okay. And now you are like master in group or ungrouped data. When somebody asks you, okay, this one is easy, let me explain it to you, for instance. Okay. Alright. So this one is explanation of measure of dispersions. Okay. So the measure of central tendency give only partial informations, locations about data set around the center. Okay. So we also need to measure that. We also need a measurement that can provide some informations about the variations. How close or how far the data disperse. Do you know what is disperse? I don't know how to explain disperse. Disperse? What is disperse in bahasa? Serakan. Serakan or serakan? Yes, that is disperse. Somebody do disperse. Like that is disperse. Yes, correct. Not cerai. I think serakan. I don't know. But that is the serakan. Okay. Like to describe how much the observation differ from the other. You want to see like the distance. Okay. So for example here, if your nature guide told you that river ahead average 3 feet in the depth, would you want to wade across on foot without additional information? So what does it mean here? Like somebody say, let's say somebody say 3 meter depth. You might argue like, betul ke 3 meter? That is like normal human being. Probably you say, probably like not 3 meter. Probably somebody might think, okay, this one probably like 4. We don't know. So when somebody think, okay, this one probably like average 3 feet. Somebody might think, okay, this one probably like 2. Probably that 4. So 2, 4, that is like dispersed from the 3 there. Okay. What else? Okay, what is this one? Okay, so example, the following table give 3 different samples which all have the same mean and median, which is 45. Okay, but have completely different spread. Okay, like based on the examples here, I don't do the calculations there. Correct, 45. So if we have 3 samples here, we have sample 1, we have sample 2, we have sample 3. And if you calculate mean, based on the infos there, I don't calculate, guys. So based on the infos there, you can see like mean and medians are 45. Okay, but when you see at the data there, like the data is not around 45. Correct? Like the first one we have like 70 there. Second one we have like around 40, but we have 70. And third sample we can say, okay, this data makes sense. Like you can see here, like we have so many false there. Okay, so what is dispersed here? This one, it has the largest dispersed. Like because we have very small, which is 20, then we have 70, like slightly large, so very dispersed. Okay, but sample 3 here, because the data is around 45, then we have small dispersed. I don't know how to explain dispersed like using words, but can you see like sample 1 is like larger dispersed compared to sample 3? Can you see that? Okay. So in terms of performance, guys, which one do you want? Larger dispersed or smaller dispersed? It depends on data. What does it mean? Let's say we're talking about your grades, guys. Let's say most of you get 90 and above. Obviously that dispersed is small, right? Because everybody get 90 and 100. So dispersed is very small, which is good. Okay? Dispersed small, good. We may think like dispersed small, good. Not. That one is good. But let's say if you have like 0 to 10, your marks now. Dispersed is small or what? Small. But is it good? Yes. So the large or the small of dispersed does not really say it's good. It depends on what data you have. Okay. Alright, so 3 common dispersion measurement: range, interquartile, and variance standard deviations. Range. Range is the simplest one. Don't get wrong answer for the range, guys. So how to calculate the range? That range is the simplest numerical measure of dispersion. Simplest. Like the easiest ones. Okay. And how to calculate range? We have first one, we have maximum minus minimum. This one is for? This one is straight. Oops. What color should I use? This one is for ungroup. Okay. Take the largest one minus the lowest one for ungroup data. Okay. But for group data, how to find the range? Take the upper limits of the last class. Okay. Minus the lower limit of the first class. Okay. Alright. And for range, we have disadvantages here. First one is influenced by outliers. What is outliers? Can you give example like how? Yes, Neil.
Ada jurang yang sangat jauh.
Jurang yang sangat jauh, correct? For instance, like Mio 100, the rest like 20, 10, 20, 10. For instance. So that 100 is outlier, guys. Okay? And normally, people think outlier is a bad one. Normally. But in that case just now, that outlier is not the bad one. Because like Mio got 100, the rest got 10, 20. Even though the 100 is outlier, but that outlier is not the bad one. That is the good outlier. Clear? Okay. So on the other hand, let's say now Mio get 10. The rest got 190. So Mio is also outlier now, but now is not the good one lah. Okay? So why we need outlier? Why we have to identify outliers there? Probably I key in your marks wrong. Then I check, oh, probably like, because like, oh, why this one 100? Then I check, oh, no, why this one is 10? Probably when I check, oh, this one should be 100. Probably. Okay, so we need to check outlier. Okay. And second one is we only consider two values. Right, because we take the highest one minus the lowest one. So if we have outlier, then our range is very huge. Okay, so not the good one for the range, but we have ideas. Okay. Alright, the following table represents the temperature in two different cities. Calculate the range for San Francisco and San Luis. Calculate the range. So for San Francisco, what is the range? 20? 12? 12? 12? The answer is there, but let me put first. St. Louis? 14. 49. I think I have answers. Let me see. Do I have answers? Yes, the range for San Francisco is 12 and for St. Louis is 49. How do we get 12? We take 63 minus 51. And for St. Louis, we take 79 minus 30. And this one is ungrouped data. Yes? Okay. Alright, next one is interquartile range, IQR. Okay. What is quartile, guys? Suhu? Suku, okay. Yes, correct. Suku is correct. Quarter. Okay. So what is inter? Dalam suku. What is inter? Like inter asasi, what does it mean? Antara asasi, right? So interquartile antara suku. Somebody say suku just now. So we use antara suku. Okay? Get it? Okay. So when we have antara suku here or interquartile here, so how many suku we have, guys? That is like, I don't know, like quarters like suku, right? So how many quarters we have? 3? 4? How many quarters we have? What is quarters in fraction, guys? What is suku in fraction? 1 over 3? Okay. 1 over 4, correct. Suku is 1 over 4. So how many quarters we have? 4. So total quarters we have 4. Okay, total suku we have 4. Okay. So this one we say just now interquartile or antara suku. We use that is nice word to antara suku. At least you understand. Okay. So we have 4 quarters. Okay. So which quarters we need to get or we need to use to calculate the interquartile? Because we may have like Q1, Q2, Q3, Q4. So which suku we need to use? Yes, we need to use Q3 and Q1, not Q2 and Q4. Okay, so antara suku or interquartile Q3, Q1. So that's why this is the formulas. IQR equals to Q3, Q1. So Q3 is suku 3 or third quarter, and Q1 is like first quarter. Okay. And what is Q2, guys? Like obviously if you have Q3, Q1, we do have like Q2 and we do have like Q4. Okay. What is Q2? Yes, Q2 is median. Because Q2 is like, just now we say like suku is 1/4, right? So second suku is like 2/4. What is 2/4? Which is 1/2. What is 1/2? 50 or 50%. So what is 50%? Goes back to median. So basically like we can calculate Q2 using the median form. Okay. Alright, and definitions here is IQR equals to Q3 minus Q1. Antara suku. Okay. Don't ask me, can we take Q4 minus Q2? Like probably like you may, because I just think that question just now, because like Q3 minus Q1, like around that, right? So can we take Q4 minus Q2? That's a good question too, but I need to find answer, guys. Okay. Alright, so what is interquartile range? Tell us how closely the values of a data set cluster around the median. So this is definitions. Okay, so that is the question just now I asked myself, and I know the answers now. We cannot take Q4 minus Q2. Do you know why? Even though you may argue like, if Q3 minus Q1 around 50%, like because 75 minus 25, right? 50%. If we take Q4 minus Q2, also 50%, right? But we cannot take the Q4 minus Q2 because of the definitions. Okay, it says like how closely the values of a data set cluster around the median. So if we take Q3 minus, like that I draw here. So we have like Q1, Q2, Q3, and this one is Q4, right? Oh no, this one is messy. Let me do it. Okay. So we have Q1. Oh, not Q1. So we have Q1, we have Q2, we have Q3. Assume they are like equally divided. Okay. And obviously you can say this one is the median, right? So by definition it says like clustered around the median. So basically around the median still. So that's why we need to take Q3 minus Q1. So if you take Q4 minus Q2, is it clustered around the median? No. Clear? Alright, okay. These are the quartiles, guys. And because of suku just now, when somebody say 1/4, that's why we have 25%. Agree?
Yes.
Second one, another 25%. Third one, another 25%. And last one is 25. So total is 100%. Okay. So first quartile, which one is first quartile? This one. Okay. Second quartile? This one. Not just 25 there. Okay. Third quartile? This one. Okay. And if fourth quartile is the whole thing, 100%. And you can see here, the second quartile separate the lowest 50% of data from the upper 50%. It is the same as the median. I think I have one example. I don't know which example. This one is what? Okay. Computing quartiles Q1 and Q3 for ungrouped data. Right? So first one, arrange data in the ascending order. Find the depth of Q1 and Q3. Determine the values based on the position. Okay. So this one, quartile one is very tricky one. They are like some argument like use this way and this way. Okay. We will see here how they use this one. Okay. So example here, followings are the final exam score, arranged in increasing order from 28 students. Okay. 28 students. So find the first quartile of the score. And I think 70 is the answer here, correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So question here, like we have 28 students here. This one is 14, down here is 14 too. So balance, right? And you see here, find the first quartile of the score, and answer is 70. How do you get 70? Yes, because if you see there is no 70. How do you get 70? The answer is 70 here. How do you get 70? How do we get 70? Ideas? How do we get 70? Yes, somebody says 69 plus 71 divided by 2. Remember guys, how do we calculate median last time? It depends on odd or even number, correct? Like if odd numbers slightly different, even numbers slightly different. Okay, so to calculate Q1, you have to divide the data first. Like this one we have divided like 14, 14, right? Okay, so this one is like the first half of the data. The down here is like the second half of the data. So basically, if you consider only the first half, then if you find the median for the first half, then that is our Q1. So how many data we have here? First half. 14, right? So 14 is even or odd number? Even number. So even number basically we have to take 7, 7, right? So if you calculate like 1, 2, 3, 4, 5, 6, 7. So this side 7. And this side is also 7, right? So balance 7, 7. Okay? And in between here, correct? The median should be in between, right? So if the median is in between, what do we have to do? Take the average of the two numbers. So you have to take 69 plus 71 divided by 2, and this one is 70. And how do we get 83? Same, which is 82 plus 34 divided by 2. So this one is 83. Clear? Okay? Alright. So now we have Q1 and we have Q3. So what is the IQR here? So 83 minus 70. Answer is 13. 13, right? Yes. Question. Examples 2. This one go back. Do now before you go back. Do this one first. I think answer is there. No, but make sure like you know how to get 79.5, 102.1, 22.6. Because later when you want to tiru somebody, tiru the trusted one, guys. Okay. Make sure you know how to get 79.5, 102.1, and 22.6. We have to have data there. We have to sort first, from smallest to largest. Do you get it? Q1 is 79.5. Yes? Or you have different answer? Circle this one. Who else? Do you have the same answer? No? Okay, what is the answer? What is Q1? Tujuh sembilan enam lima. Q3 1 10075. Yes. IQR IQR 21.1. Okay. Q1 is 79.65, Q3 is 100.75, IQR is 21.1. Correct? Okay, that's it. We stop here. We will continue tomorrow variance. I don't want to cover variance now.